we want to simplify the given expressions involving factorials. So let's start with a review of factorials. For n factorial, n is a positive integer, where n factorial is the product of the positive integers less than or equal to n. So notice for n factorial, the first factor is n, followed by a factor of n minus 1, so this factor is 1 less than the first factor, and so on, all the way down to the factor of positive 1. So for example, 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. We can also write n factorial as a factor of n times n minus 1 factorial. For example, 8 factorial can be written as 8 times 7 factorial. And by definition, 0 factorial is equal to 1. So going back to our two examples, there's a long way and a short way of simplifying these, and we'll go ahead and show both. The long way would be to start expanding each factorial. For example, k factorial would first contain a factor of k, followed by a factor of k minus 1, followed by a factor of k minus 2. Notice each factor is decreasing by 1. So the next factor would be k minus 3. This would continue all the way down to a factor of 2 and then 1. And then for k minus 2 factorial, the first factor would be k minus 2, which I'll go ahead and put over here. Notice the next factor would be 1 less than k minus 2. Well, k minus 2 minus 1 is k minus 3. And again, this would continue all the way down to a factor of 2 and a factor of 1. Now that we've expanded these, we should recognize that we can simplify this fraction because the numerator and denominator share common factors. K minus 2 over k minus 2 simplifies to 1. K minus 3 over k minus 3 simplifies to 1. Notice all the remaining factors would simplify to 1 over 1, which means this simplifies to two factors, k times k minus 1, or if we want to expand this by distributing, we could express this as k squared minus k. Let's go and simplify this again using a slightly different method. As we begin to expand k factorial, notice how we have a denominator of k minus 2 factorial. As we begin to expand k factorial, we can write k factorial as k times a factor of k minus 1. But notice how now the remaining factors would be k minus 2 factorial, which matches our denominator. So we can go ahead and just simplify k minus 2 factorial over k minus 2 factorial. And notice how the result, of course, is the same. We have k times k minus 1, which is still equal to k squared minus k. Notice how the second method is a little more precise and actually less work. So if we can recognize when we have two equal factorials, it can save us some time. Looking at the second example, again, we'll start by just expanding both factorials. So the first factor of k plus 2 factorial, of course, is k plus 2. The next factor is going to decrease by 1. K plus 2 minus 1 is k plus 1, followed by k. The next factor would be k minus 1, followed by k minus 2, and so on, all the way to a factor of 2 and then 1. And then for k minus 1 factorial, the first factor is k minus 1. Subtract 1 from k minus 1, we have k minus 2. Notice how these factors are matching up with the numerator all the way down to 2 times 1. So once again, we can see we have common factors in the numerator and denominator that will simplify to 1, k minus 1 over k minus 1, k minus 2 over k minus 2, and so on, all the way to 2 over 2 and 1 over 1. We can see this simplifies to three factors. We have a factor of k plus 2, factor of k plus 1, and a factor of k, which I'm going to go ahead and write as k times k plus 1 times k plus 2. I'll go ahead and multiply this out. Let's multiply the two binomials first. So we would have k times k squared. Then we have k times 2, that's 2k. 1 times k is 1k, so that's plus 3k plus 2. And we'll go ahead and distribute. So we'll have k to the third plus 3k squared plus 2k. So if you can leave it in factored form, we can leave it in this form here. If we need to multiply it out, we would have this expression here. I also want to show this another way. Again, if we recognize that we have k minus 1 factorial in the denominator, as we begin to expand the numerator, we'd have a factor of k plus 2 times a factor of k plus 1 times a factor of k times the next factor would be k minus 1. Therefore, we can write this as k minus 1 factorial. Notice how k minus 1 factorial over k minus 1 factorial will leave us with the same three factors, k plus 2 times k plus 1 times k, or in factored form, k times k plus 1 times k plus 2. Or if we needed to expand this, we would end up with the same expression we have here. Okay, I hope you found this explanation helpful.